I'm Nirmal Patel, currently pursuing my bachelor's in computer from the Gujarat Power Engineering and Research Institute, which is situated at Mehsana, Gujarat. I'm here to present my work, Attainment of Green Computing in Cloudlet-based mobile cloud computing model using SSA algorithm. And I would like to thank the organizer and my mentor, Dr. Kushal Anjaria, for providing me such a good opportunity to present this paper. And my paper ID is 81. So I'm starting now the presentation. Yes, starting with the outline. Please have a look on the main points that are necessary for this paper. And I will cover introduction, concepts, challenges, then SSI and proposed solution, followed by case study and the comparison with ACO, which stand for Ant Colony Optimization Algorithm. Okay, now let me tell you that there are two main reasons for the energy consumption in mobile cloud computing. As mentioned in the slide, one reason is a weak network link between the cloudlet and the cloud and the mobile, which leads higher energy requirement. And the second reason is devices, which continuously searching for the signals may dry out the energy of the devices. Actually, these two reasons are the challenges to be solved for the attainment of green computing, right? As you know, dry out required a huge amount of energy, which plays an important role in operational cost as well as the carbon footprints. Present work will show not just the solution but the optimized solution, because there have some works previously done by the researchers. Here you can see I have mentioned three researches which have been done on this. The first is done by Mr. Arihar and the team on the how to reduce ICT carbon footprint through the green computing. But the adapted approach is based on upgradation and recycling, where the cloudlets are not considered at all, which is not so fruitful. In the second research, Mr. Guy and the team found a solution, but it was too time consuming, so it was not so fruitful. And the third research, which is done by Mr. Kushal and the team, found a solution based on natural inspired algorithm, and they have considered free VM vectors and the time. But I will show you how SSA based solution is more optimized and give optimum solution. Before moving to the actual solution, let me tell you that the core of this work is the three-tier architecture of the MCC structure, where the tier 1 consisting of the mobile devices, tier 2 consisting of the cloudlets, which are required and are working as a serving agent, and also responsible for mobile connection of the mobile devices with the third tier core cloudlet, where the virtual machines are placed. Also, these machines are responsible for serving the request of the mobile devices. Now moving to the next slide, let me tell you that the former challenges mentioned in the former slides can be overcome if the mobile device is able to communicate with the nearest cloudlet. Then the link will be strong and the energy wastage will definitely decrease. There are many parameters and measures available to calculate the energy consumption. They are mentioned in the literature. Here we have concluded two parameters with which we have solved this problem efficiently. The first parameter is a linear distance between the cloudlet and the mobile device, whereas the second parameter is the non-allocated VMs in the core cloudlet. Moving to the next slide, here you can see the symbols and abbreviated form that are mentioned in the slide, because they will be used in the further slides, so you should not have any confusion regarding this. The first is the SSA, which stands for Squirrel Search Algorithm, derived from the locomotion of the squirrels. Second is ACO, which stands for Ant Colony Optimization. There is a correction, not simulation, optimization, which is derived from the path routing behavior of the ants, and followed by NT, AT and ST. I will define this term while introducing the algorithm, and then you know this VM, cloudlets and the mobile devices. Moving to the next slide. Now look at the figure. I have mentioned three mobile devices, M1, M2, M3, and the cloudlets ranging from C1 to CA. Especially you can see that the four cloudlets are connected with the mobile 1, from which one device, one cloudlet will serve the request of mobile device M1, and that will be chosen by the SSA algorithm. Here is the function given, function of LD-VM, is the minimization function, where hyphen denote that the virtual machine should be maximized and a linear distance should be minimized. Okay, now let me tell you that SSA algorithm was firstly introduced by Mr. Jain and the team as a natural inspired algorithm. Uh, the whole idea of the algorithm is engaged with the way of finding food by the squirrels, and mainly this squirrel consume two type of food: acorn nuts from acorn tree and the hickory nuts from hickory tree. Squirrels are assumed to have their homes on the normal tree, and acorn nuts are used as a daily nutrition, whereas the hickory nuts are stored for the winter because these squirrels generally don't glide in the winter season. Now, based on their needs of food and the gliding distance, simulation of algorithm can be done by three ways, from which we have selected the third way as mentioned in the slide, distance and a food specific, which is based on a efficient according to statistical analysis. Now, now let me tell you that the squirrels having instinct to choose the tree based on food. There are three cases that have been derived by Mr. Jain and the team in the algorithm. That first case is the normal tree to acorn tree. The second is acorn to hickory tree, and the third is when squirrels are assumed to having nutrition and directly foraging to the hickory tree. Then the third case can be applied. And in our proposed solution, we have considered mobile device as a squirrels, cloudlets as a type of tree depending on the distance, and a VM as a food. And also the attempt of connecting is the considered as a glide of a squirrel. Now, yes, we have seen this figure earlier in which some mobile devices and cloudlets are included. Now let me tell you that the C3 device will consider as a base solution according to the function that I have introduced and work as a hickory tree, which is the efficient solution according to SSA. I will show you how that work. And if in case C3 is not able to serve the request of M1 device, then the efficient solution from next three device will serve as a hickory tree, which shows that mobile device never need to search for the signals in all the cloudlets, whereas the hickory that mobile device have to connect with a direct hickory tree, which is the efficient one. And in the rare case that still not happened while our analysis, that if all the four cloudlets are not able to connect with the mobile devices and not able to provide the service, then still in the bounded area A, any of the cloudlet which are not connected, they can provide a service, but with the draining, which shows that the mobile never lose the connection in this area. Now moving to the next slide. Yes, here are the symbols which are used for the squirrel positioning in the SSA algorithm. First five are the symbols for the location, and the 6 and 7 are the constant which are significant for the execution of the algorithm. The value of this constant are chosen as per the statistical analysis, as well as the one parameter is chosen from previously done work, which was SSA GC equals to 1.901. Now let me introduce the pseudocode. Actually, equation 1 and equation 2 are required for the initialization of SSA algorithm. Here, if you are considering n squirrels in the bounded area A with the j dimension, then we need to create an n cross j matrix with the squirrel position, and this squirrel position can be found by the implementation of the equation number 2. Now, as I discussed, there are three cases that squirrel can move from. Then we have equations for them to apply in the simulator. If we are considering K1 squirrels are moving from normal acorn tree to hickory tree, then the equation 3 can be implemented to find the updated location of the squirrel. If we are considering K2 squirrels moving from normal tree to acorn tree, then we can find the updated location by the equation number 4. And in the rare case, if squirrels is moving from normal tree to directly hickory tree, then equation 5 can be implemented. Let me tell you that after the execution of the algorithm, if the squirrel's position is on the hickory tree, means it found a efficient solution. And also here is the seasonal constant, because as I told, Oh, I'm sorry, I missed the slide. Yes, I have introduced a seasonal constant here because as I said that squirrels don't glide in the winter, so for that we have Sn constant here, and this is the end of okay. Now let me introduce the simulator. Actually, we have used this algorithm to find a solution in MCC structure. So we have designed a simulator with this some features like user can create instances of a mobile devices and the cloudlets, also provide the virtual machines, processes, and also when we run the algorithm, a red line will denote the connection between mobile device and a cloudlet, which is normal, but the blue line denote the efficient solution every time. To explain it further, let me show you the case study and example. Here I have mentioned some of the input which I give to perform the example, the number of clouds, VMs, area A, and the processes. To explain it further, yes, you can see here two images from which the left side image shows that the initialization phase where all the cloudlet and the mobile instances are created. On the right side image, you can see the connection establishment phase where they all have the normal connection with each other, particularly mobile with the all cloudlets. And here you can see after the running the SS algorithm in the MCC structure, there is a blue line between the mobile and a cloudlet, which shows that it found a efficient solution. Now, if you are moving your mobile device in the bounded area, then what happen? The next efficient solution automatically turn its link to a blue, and the previous connection will be cut off. So your mobile never need to search if you are losing the previous cell and moving to the next cell. So automatically done it by the algorithm. Now let me tell you that we have found a SSA efficient solution by the comparison with the ACO algorithm. The simulator of ACO algorithm was designed by the Mr. Kushal and the team, and we have performed a solution, performed the example, what is example with the different inputs, and found that the SSA is performing well. Let me show you how. Here is the input given to the both the algorithm, and we got this. Here is the images. Left side image shows the simulation in SSA, whereas the right side image shows the simulation in SSA. Sorry, correction. Left side is the ACO and the right side is the SSA. And the mobile device, here you can see this mobile is connected with the upper cloudlet, whereas the in the SSA same mobile device is connected with the lower cloudlet. To explain it further, you can see this table. Here mobile 1 and mobile 3 are connected with the same cloudlet, but here is the variation. ACO choose the C1 cloudlet, whereas SSS chose a C2 cloudlet, and you can see the distance difference between them. The cloudlet 1 is connected with the 3.0020, whereas the cloudlet 2 is 2.5495. So it's clearly visible that the C2 device is the efficient solution. This is please note that this is the example just to explain. In the real case, there will be lots of devices in the area, which is fruitful for the SSA algorithm, because Mr. Jain and the team have derived that with increasing number of node, the solution will be efficient. And yes, we have provided a novel approach using the dynamic cloudlet based MCC to gain the green computing, and also our experimental result and statistical analysis says that the SSA provide a globally effective and the efficient solution for this unconstrained optimization problem, and also observed that in the most cases SSA provide a optimum solution compared to ACO. Okay, so here are the references that are used in the presentation, and that's it about the presentation. Please, hello, questions if you have any. Hello, hello, I'm audible. Am I audible?
Hello, Nirmal?
Yes, yes.
Yes, ma'am. That's the end of my presentation. You can ask me the questions if you have.
Yes, you can go ahead, Nirmal.
Hello, ma'am. Yes. Hello.
Your voice is a little distracting. Nirmal, are you there?
Yes, ma'am. Yes. Am I audible? Hello. Hello.
Yeah, you can go ahead with the next slide.
Yes, yes. Nirmal, I
Yes,
have a
sir.
query.
Yes, yes, sir.
Yes, you can go ahead with the next slide,
What
Nirmal.
cloudlet?
Your voice is mixing up, sir. Can you revise the
What is
question?
cloudlet? Cloudlet.
Okay. Yeah. 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 Let me tell you. Here, when the mobile device is requesting for the services, cloud services, then there are two tiers. A second tier cloudlet, which is serving as a serving agent, service as a serving agent, and are responsible for the connection of the mobile device to the core cloudlets, where the virtual machines are parallelly processing. If you are requesting for some resources, then this virtual machine will provide you a resources from the core cloudlets. So there are the cloudlet consisting of the number of virtual machines, software and the hardware.
Okay, means cloudlet is a job. Uh, I'm audible.
Yes, sir. Yes, sir.
So cloudlet is a job or request submitted to the virtual machine for the education.
Yeah.
Am I right?
Yes, sir.
Uh, so what parameter you have done and decided for the single cloudlet?
For what, sir? Pardon?
Cloudlet is number of million instruction per second. Million instructions is not. If a cloudlet there is a number of million instructions. So what size of the a single cloudlet?
Actually, sir, we have okay. I got you. Actually, sir, we have here parameters that processes a single request, a single processes. Like we are right now, what we are doing, we have to do nothing with the processes and the further processing. We just need to provide a path that when we are facing the problem while handoff,
Okay.
that signals is not working well or draining lots of energy, that we have to done here, not the core work with the processes. So we get a parameter that the for the single request of the mobile devices, we need to provide with the one virtual machine. It's just a assumption. Also, that can be optimized, that can be modified, but here our work is what about to providing a path, about to how to select a path and minimize the energy consumption. Am I audible, sir?
As the title, you have chosen Squirrel approach. Am I right?
Yes, squirrel search approach.
Why?
Yes, sir.
Why there are many other approach like ant colony updation
Yes, yes,
and
sir.
very
Yes, sir.
many some yes.
Let me
So why
tell you.
Squirrel approach?
Let me tell you that this work is done by me and Mr. Kushal Anjaria, who have done a work on the ACO simulator. On the previous year, they have done a work with some other researchers that how to apply ACO in the same mobile cloud computing architecture and how to find the path. They have a work on them, but I found that maybe the SSA having some functionality and some better approach than SSA. That's why I designed a simulator and then perform a statistical analysis with the ACO also and the SSA in the both the algorithm, and I found that SSA is working well than the ACO. Hello, is that Preeti ma'am? Are you there?
Wait a while, Nirmal.
Okay, sir. Okay.
Let's.
No.
In meanwhile, do you focus what about network overhead? Uh, about your research? work.
Hello.
Am I audible?
Yes, yes, sir. Yes, sir.
What about network overhead?
Network overhead. Pardon me. Can you explain it more? What you want to ask?
Yes, yes. Please explain.
Actually,
In respect to your work.
Actually, sir, in this paper, what we have done, there is already a approach is defined by Mr. Kusal and the team that ACO can be applied over the rigid method to connect with mobile with the cloudlets. Right? They have
Okay,
found a
okay.
solution that there is already
Yes.
a hello. Am I audible, sir?
Yes, yes, sir. Yes, yes.
Okay.
Go ahead.
So there is a ACO. They come up with the ACO and the solution that we can optimize our connectivity by the ACO. But then I searched over internet and found that SEO having same parameters and something like that. We can if we design a simulator with MCC structure, then still we can optimize more. Still we can get a more efficient solution in compared to ACO. So that I decided to make a simulator with SSA algorithm in MCC structure. So here what I'm doing, choosing this algorithm and implementing in the MCC structure. And then I did a analysis, statistical analysis with the same input in both the algorithm and found the solution that SSA give a optimum solution than the ACO. So that is all about my work.
Okay, thank you. Kriti ma'am, over to you.
Yes,
Yeah,
ma'am.
can you hear me now clearly?
Yes, yes,
Yes,
yes,
yes.
ma'am.
Yeah. So I have two questions for you. One is when you use a cloudlets. Normally, cloudlets you use for a small data centers,
Yes,
and every mobile device which is connected, it will demand the resources. Now,
yep.
in your slide, equation number 5, my question was, did you consider the two things? One is the resource limitation, other is the load balancing. Let me just ask you the questions more clearly. Is like if you have 5 cloudlets
Yep.
and assume that all the 5 together can satisfy the request of one of the mobile devices. So are they sharing the resources?
No, ma'am. Actually, what I have done in this paper, that if there are all five cloudlets are able to serve the request, right? So, but what happen? There will be some difference between the distance to the mobile devices, right? As I mentioned, the function of LD
Okay.
and LD and the hyphen VM. if if the linear distance is same between all the cloudlets, like let we assume that all the cloudlets are on the same distance, right? Then what happen, there is a next parameter, VM, virtual machines. If there are more virtual machines free in the some cloudlet, then it's a globally optimum solution, right? It can perform very well. So that cloudlet will be selected and the rest of all will be the backup. In case the first one is full or getting load, then the other cloudlet will serve. That way it will serve the requests. And yes, let me tell you, ma'am, that we can also
Okay.
modify.
And the second,
Okay,
yeah,
okay, ma'am. Okay,
I,
ma'am.
the second question is how many mobile devices have you tested for the cloudlets?
Actually, ma'am, we have used for the large range of input. Actually, more than 50 is the limitation. As we have mentioned in our paper that at least there should be a 15 devices in the bounded area for checking the dynamic behavior. Because as we know that swarm intelligence and evolutionary algorithms are not working well in the lower devices, as well as in the real scenario there will be a more devices also. So we cannot conclude our work with 2 or 3 devices, as I shown in the slides. But we have considered the more than 50 devices, more than same with the same input range, with the same virtual machines, and sometimes with the same processes also, and also moved all the device in the bounded area. And then we have done a statistical analysis with the ACO with same input range, same virtual machines, and then we compared both the tables, and then found that SSA provided such a good with the efficient solution.
Yeah. Any other question from participants and authors?
Yes, ma'am. I have one question to you, sir. How you are going to manage the power consumption occurring due to latency during this
Yeah,
algorithm?
actually that will be the my future aspect I haven't mentioned, but let me tell you that right now I have proposed a solution that this can be a solution. Right now I will do that mathematical all the stuff, and then I will come up with the solution, and with the better consumption that right now how much power consumption can be made, and what ACO's power consumption, and then SS's power consumption with compared to ACO. So that will be my future. That will be the next work.
Okay, thank you.
Right. I think that was Vinodini asking question, right?
Yes, ma'am.
Okay. Okay. Any more questions from anyone? Right. Thank you, Nirmal Patel. So I would like to thank all the authors and all the presenters for coming to this session. All the papers were excellent, and all of you have kept really very nice efforts to present the papers. However, we have to select the best paper in this session, and I have the results ready in my hand as per our panelists. Before I tell you the best paper, I would like to thank our panelists also. So thank you so much, Santanya Mani Tripathi sir. Thank you so much, Balkrishna sir. Thank you so much, Mohan Raj sir. Thank you, Sonam ma'am.
Thank you, ma'am.
Yeah, thank you so much, sir, because they were all constantly observing you, all the presenters, and now I have the results in my hand, for which all of you must be waiting. So, as per all the parameters and as per the rules of the panelists, now let me announce the results. So, let me start with the paper title so you can guess it. So, the best paper goes to. Right. So it's the paper title Attainment of Green Computing in Cloudlet Based Mobile Cloud Computing Model using Squirrel Search Algorithms. This paper ID 81. And many congratulations, Nirmal Patel. Can you please come quickly online? Can
Yes,
all
yes,
of us
yes.
your face? We want to see your happy face.
Thank you very much, ma'am.
Yeah, congratulations, Nirmal, and wish you all the best.
Thank
And
you,
wish
thank you.
all the participants all the best. Yes, stay safe, take care, and we will be in touch in future conferences also.